This is so interesting I could puke, and Melchior has been working on a generator, I think. It's the best that I can understand because I'm a layman. Melchior, tell them who you are and what the hell you're on about, bro. It's super interesting.
I'm Melchior, a 38-year-old jack of all trades, master of none. Been everywhere, done everything, haven't mastered any of it. So, yeah, the concept of this thing actually came from an idea that my father in law saw while he was traveling in Mauritius in a hotel. Walked in the lobby and he saw this funny contraption there with air and water on a spinning conveyor
What
belt,
the
basically.
hell? What was it?
So it's basically just an ornament they had in their lobby. So we thought, okay, buoyancy plus gravity, why can't we use that to generate electricity?
Okay.
So they actually built the first one before I got involved. The first one was very, how can I say, primitive. What I'm using compressed air and all of that. So you kind of still had to have an input because you couldn't generate your compressed air without electricity. So that's where I came along and said, okay, why don't we make it so that we start it up with a dive tank, so meaning you don't need electricity, and then once it's running, get it to generate its own air.
So the dive tank is kind of like on the old cars. It's the hand crank that gets the engine moving.
Basically, it's just to get the whole contraption moving, but obviously now supersized. So I've actually made some notes here. So this plant, it's how can I say, it's to do with size and what I mean. Everybody's doing solar farms now. And I mean, your footprint on a solar farm, a small solar farm, is what, about 24,000 square meters. Our plant only uses 81 square meters.
Sure. Big reduction.
So your impact in the environment is minimal, all of
Are you
that.
using
And we can
height to
build.
overcome that, or what? Or is it just the unit is smaller for the same output?
So the unit is smaller, but we're also using
Mm,
height. I can't recall. I think I sent you a video some time ago of a plant that was buried in
yes.
the ground. It's like 16
Yeah.
meters deep. So the newer plant won't be in the ground, because you need to look at, how can I say, serviceability and all of that. So yeah, that's where the whole idea came, to build a structure above ground, which is basically 8 by 8 square meter platform with a steel tank structure on, with a whole bucket system, everything on the inside. So then it's got a little control room where you can start it up, all of that, and then we can build it to generate 450 megawatts up to megawatts
Yeah, yeah. So like I
of
don't
power.
understand megawatts and everything. What is that? Can you explain that like in a way that makes sense to me?
so so let's put it like this: ESCOM needs to keep the South African grid running. As far as I can recall, they use about 36 megawatts to keep the South African grid running.
Hmm.
For us, we can basically build a plant that produces 1 megawatt of that. So you can run, for instance, a small town like Edenvale, or, you know, obviously the bigger the town, the more power you have. So our focus with this would actually be more for the guys like in your farming industry or your private complexes where they want to step away from the grid, and you can generate your own power. And if you get everybody, say now you're in a little housing development, everybody pays you for the electricity. Within a couple of years you pay the plant off, and then you don't have to pay ESCOM.
It's a bonus, yes. So you said it works on buoyancy and flotation and things like that, and air and
Yeah. So basically, what it is, it's a submerged structure that's got tanks on. So, for instance, our demo one's got 72 tanks on, which runs on I almost want to say a chain and sprocket system. So what happens is, as it rotates, at the bottom you fill it up with air to create buoyancy, and at the top you fill it up with water to create gravity. So it's kinetic energy. It's just a different way of doing it. Where guys, I mean, if you look at your EVs now and your hybrids, they basically use braking, stopping power. Yeah, to what's up? So they're using kinetic energy to recharge their batteries to keep their cars moving
wow,
forward.
okay, okay, yeah. So that reminds me a little bit of the way submarines rise and fall in the water with pumping air into the, what do you call it? I suppose swim bladder, essentially.
Yeah, so it's basically displacing water with air and then displacing air
Mm,
with water once they want to submerge again.
okay. So after you've started the cycle moving with a dive tank and it starts creating its own air, like pumping its own air in there, pressurizing its own air, it just kind of runs perpetually until you stop it, or what's the situation?
It will just keep on running until you stop it. Uh, so where the trick came in is obviously with the amount of torque that comes off that plant. So there's where the secret sauce comes in from my side. So currently it's a bit of a grey area, if I can put it that way. But we basically taking minimal revolutions on the one side, speeding it up so that the generator can actually generate the electricity that you need. So gearbox, but the amount of torque that comes off there is so immense that you can't find a manufacturer that builds gearboxes for this. We had to invent it
Okay, that's
ourselves.
like, yeah.
So the amount of torque that comes off this is between 25 and 49,000 Newton meters of
Oh,
torque.
yes, like, okay. You're, good Lord. Good Lord. Okay. And just, yeah, that's a hell of a lot. So, using that torque, okay. So you've put a gearbox on this thing, right? So you've got this system that's
Yeah.
wanting to run like an absolute bastard, and you're throttling that back with a gearbox to kind of create that resistance that then generates what's slower. It slows the movement
So
down.
so so we actually speeding it up.
Oh shit. Okay.
Yeah. So for instance, you like in one of the industries that I came from, their machines used, because you've got a lot of wear the more revolutions you've got on a motor. So if you run a motor at 9,000 RPMs the whole time, your failure rate is a lot higher than on a vehicle where you get the same amount of power but you're running at 3,500 RPM. So basically, what we doing is we running, for instance, a 1 to 500 ratio or a 1 to 50, depending on what the application is. So, for instance, say I'm going to use it as an example. So now our input is 15 revolutions per minute, but for us to generate 100 100 kilowatts, we need to do 200 revolutions on the generator side. So we need to build a gearbox which will run basically from a 3 to 200 ratio or a 1 to 500 ratio, all of that.
Sure. That's a big difference.
Yeah, but then also you need to time everything. So you need to time how much air you pump in, how often you pump it in, all of that, to get the thing. to work properly, but also not run away from you. Because if it runs away, then you've got big problems. Because how do you stop with that amount of torque unless you put in a, how can I say, make the gearbox so the gearbox disengages?
So it sounds like the process of stopping it would be a mechanical one and not an electrical one. It wouldn't be a case of disconnecting like an electrical connection. It wouldn't be a case of disconnecting the air connection. It would be a case of we literally have to sort of drum and block break this bastard and stop it physically. Is that right?
So, because of the amount of torque that comes from it, there's no way that you're gonna stop it with a brake. So, what's the easiest way to do it? It's get the gearbox to disengage and cut your flow. So, you cut your airflow. So, cut your airflow, cut that, and just let it run till it stops. But there is some fail safes and stuff that we're busy with writing and all of that, which should prevent that. So we should be able to time it. So if it speeds up, so that it knows it needs to retard the airflow, and if it slows down, you need to speed up your airflow. If I can put it
And
that way.
the systems that you're writing will govern how that functions, almost like an ECU in a car, right? Oh, okay. Okay, that's cool. That's cool. So, what are you hoping is going to happen next with this project?
Um. So look, at the moment, it's just the, how can I say, the costs, the investment cost and all of that, because it's not something that you can do out of your pocket unless you're really really wealthy. So we're currently busy with a couple investors and all of that. I mean, the mastermind is actually on his way to Durban at the moment, to see one of our big retail, how can I say, retail chains, because they're very interested in it and they don't want to do
Okay.
solar. So we're currently working on a deal with them. So hopefully within the next, I'd say, month or so, two, we should have a go ahead from that, and then we'll start with the rollout. So first we'll finish the, how can I say, the demo model, if I can put it that way. So we want to build a working proof of concept so that we can actually get people to come through to our site and see the thing working, and then basically from there and just market it and see how far we can get it to go. So this retail chain that we're busy with, if everything goes well, we're looking at a complete rollout all over South Africa. And they will even start supplying electricity and stuff to their neighbors or their complexes where they are.
Super helpful. But now, on that note, when you've invented this thing, right? You and your partners, you invented this thing. You've got it up and running. You've got your proof of concept. How how did you get that retailer to even know what you're doing? What was the process of getting them this far?
So with the version one that we built, um, we were actually involved with a German company as well, and they kind of took the concept and they tried to run with the idea, but they could never get it to work. So, and when we picked up on it, we said, okay, let's cut ties. We're not giving them any more information from what our side. So they actually did most of the marketing for us on that
Okay.
already. So you know what they say, even bad publicity is good
Absolutely.
good for
Yeah.
marketing. Um, so they kind of shot themselves in the foot with it because they couldn't get it to work, but they created a website with a concept and all of that, and just word of mouth. So because my in-laws are in Limpopo, there's a big contention on electricity and green electricity, especially if you're more in the rural areas like farms and plots and all of that, because they sometimes sit without electricity for like 5, 6 days at a time. Um, Basically, word of mouth. And, with some of the people that stay in the surrounding areas being part of government officials, they talk. So, yeah.
So once you have, just going back, I'm thinking about this in terms of sustainability and things like that. You start the process with a dive tank. So you would need a local depot that supplies dive tanks, or would you fill your own dive tank? Say you had to switch it off for some godforsaken reason. Would you then need to use electricity to fill the dive tank and then bring the dive tank to you from a depot, or would it be a case of having a small compressor on site that you would use?
So basically, what we working on, and what I understand or what's been explained to me, um, it should be able to charge up a tank for situations like that. So you won't need it. It will just be the initial startup. So the first ever startup, you'll start it up like that with that, but after that, it will build up its own basically pressure tank for air, so that once you need to shut down for your service or whatever the situation may be, it's literally a flip of a switch and it will get itself up and running again without having to run around for dive tanks. And
My other question is around safety. So with I've seen things like gas bottles go, right, quite badly. I've seen we've seen the Titan disaster. It was last year or the year before where that sub exploded. I mean, that was obviously pressure from the outside. So it's like the inverse problem. But then if you look at all of those types of air systems, if you've got energy in any form that's stored, if it's stored in the lithium ions, the risk is fire. If it's stored in a what do you call those things that spin all the time? If it's stored in,
I like the rotors or your steam
yeah.
rotors and steam
So
turbines.
if
And
it's stuck, if it's stored in that, if it's stored in a flywheel, if it's stored in something like that, the risk is obviously fragmenting or breaking loose. When it comes to a tank, like think about steam trains, for the love of the Lord, man. When those used to go, just tubes everywhere and half a town disappears, from a train going. It's pretty crazy. What's the failure risk, and if it does blow the hell up on plough itself, what does that fallout look like versus, and how do you contain the risk of that?
so look, because you haven't got any fuel, any how can I say, you haven't got any fuel, so you're not using diesel, you're not using petrol, um you're using basically compressed air, which is in a little built, how can I say, control house. So, I mean, the worst thing that can happen is maybe a tank pops, but it will be contained in that, or the actual plant starts leaking water. But I mean, it's not so much water that it will flood a neighborhood, if I can put it like that. So theoretically, I don't see major damage. Maybe a bit of water damage, but nothing major like a dam break or a massive
The
explosion
tanks
or.
themselves aren't running at a high enough air pressure to really blow if they blow, right?
No, but also if you look at how Ford technologies come with compressors and stuff, you've got all of those pressure relief valves and all of that. So as soon as it starts overpressurizing, it opens a valve and it actually releases the pressure until it stabilizes itself again. So obviously that just becomes a part of your maintenance, if I can put it that way. It becomes a maintenance check, like a monthly health check or whatever the maintenance schedule is on that. Which obviously, um, we estimating every 3 to 5 years. But I mean, we'll only know that once the first plant's actually up and fully running. But I mean, we are busy working on fail safes and stuff to remotely, how can I say, remotely check it, make sure everything is running like it should. Even a remote cutoff, so we can be anywhere in the country. If we pick up something is wrong, we can switch it off
Cool,
immediately.
cool. And then that just kind of eases itself out until it's dead, right? When you are building something like this, that's new. That's not been done before. What are the compliance loopholes that you have to go through to get people to kind of give you the licenses or the I mean, you obviously need certifications if you're going big out into the public and into B2B, right?
So with something like this, you, how can I say, your biggest issue is basically just your materials. So your materials need to be rated at specific ratings and stuff to withstand pressure. Um, it's like, because it's water, you can't just use plain steel. You either need to use stainless steel or galvanized. Your water needs to be treated, all of that. And with power, like even with solar energy, it's not something you can patent. So it's not, if if we build it and someone else decides they want to build it, they can build it. We can't stop them from building it. The thing where we can is on the secret source, if I can put it that we can patent, because that's our, how can I say, that's our intellectual property. So that we can patent, and we can actually, anybody can build a plant and we can supply them that. They can buy that from us, but they're not allowed to do that themselves or create that themselves. South Africa is a bit weird when it comes to like energy generation and all of that. So nobody can hold the monopoly on it, if I can put it that
Okay,
way.
cool. I mean, good in a way, that prevents abuse to a certain degree, I suppose. It is it is a hell of an interesting proposition. So this is going into a major retailer. We won't say who. This is going into a state where, like you said, they can potentially provide electricity to the mall or the strip mall or the complex that they're in. How does that look as far as recoupability of your like ROI essentially? If you look at it like this retailer is going to put in, say they put in 1 million, right? Just to give you a nice, easy, low round number. They put in 1 million, they say, cool, put it in a store. What type of thing would it look like for them to then manage that? Would that be is that something that you provide, like a management software for how much power is going out versus how much they should be charging other people? Or is that completely, they must run a meter and
So,
choose?
so basically, from our side is, say they buy the plant outright from us. So once we install it, we can help them with maintenance, all of that. But once it's installed on site and it's running, it's up to them. It's their decision if they want to charge their neighbors. If they don't, do they want to keep it to themselves and not supply anybody else? Um, so we don't want to, how can I say, we don't want to hold the monopoly on that, if I can put it that way. So we want to, they buy the plant outright from us, we install it, and once we walk away, it's their decision what they do with it. They use it, they don't use it, they sell the electricity, they get out, all of that. But it's also, I don't think it's a thing that, how can I say, once it's up and running, we're gonna do forever, if I can put it that way. I think we'll build the first couple and then see if we can't basically sell the concept and get other people to build it, and then just supply them the, how can I say, the heart of it, the stuff that the secret sauce that makes it work. Um, but yeah, like I said, at this moment, I'm not 100% sure myself. This is a thing that my father-in-law will need to make a decision on when we
No,
get there.
makes sense. I mean, this is like super grassroots, super early on in the process. I mean, it's one of the reasons why it is so interesting, like a puke, is because it's like, when do you get to speak to people that are working on something that is so new and so unique? You know, it's not a very common thing.
And the thing is, it's I don't know if I've mentioned this. This isn't something that's been coming a year or two. This is already like 6, 7 years in the making.
Yeah, yeah,
From when they initially started, it's how can I say, it's like I basically come in because I'm very technically minded. I mean, I've done a lot of technical stuff in my life, especially like with some of the companies that I worked for as a technician, all of that. I understand how things are supposed to work kind of by looking at it. And it's like, so a lot of times my father in law would come and he's like, and listen, I've done this. What do you think? Is it going to work? What do we need to change it? All of that. And then just like with some software and stuff, it's so amazing now. Some of the programs that's out there, you can basically stress test anything without having to physically build something just by putting in material specs, doing a drawing, doing a mock run, and it will tell you your failure points, if it's going to work, if it's not going to work, um, all of that. So yeah, it's. I'm not an engineer at all, but like I said, I've got an understanding.
it's fascinating, man. When you are looking at a system like this, what is the most common misunderstanding that people have? Because look, part of this will be sales, like with this retail system. Yeah, the other company, the other people, the Germans did most of the marketing and things like that. But when it comes to actually selling it, that's now on you because they're out of the picture. When when it comes to something like that, what's the most common? I suppose common is difficult because it's so early on. But what kind of questions, what kind of roadblocks are you finding in people's understanding that helps them be on the same page as you? Is it just too weird, or is it kind of like similar enough that people can process?
So at the moment, it's a bit difficult because everybody they want it, but they don't want to. How can I say, make the investment because they haven't seen the concept, and that's the whole thing. It's like if you haven't got a physical thing that actually works and shows them that it works, it's very difficult to how can I say, prove to people or motivate people to look at and say, listen, we are going to make an investment and we're pulling the trigger on that. So there's a lot of people that say yes, we want it, but they're not willing to put how can I say, put the money where their mouth is because there isn't a working concept at this stage. And this is where we hope things go the way that it looks like it's going with this major retailer, because it will give us that opportunity to build that first working plant. Um, and then obviously it's just marketing it from there. Maybe, like I said to you in our private conversations, once that first one is there, if I need to pay to fly you down to Polokwane for a week or so, then
Yeah,
we
yeah,
do it. Just get it out there, get people to see what it is, how it works, and basically the rest will do itself. I mean, people want electricity, and we don't know where our current ESCOM grid is going,
yeah,
to be honest.
for sure. So what about uh scalability of this? I don't mean scalability as in, you know, how many units can you sell. I mean scalability in terms of like miniaturizing. So if you scale this huge plant way the fuck down, could this power a scooter, a car, something like that as well in the future? Or is that a little bit worse?
I think going as far as to like transport, I think is a bit what's the name. But I mean, we are looking at options to scale it down so you can buy one for your house. So that you don't have this massive structure standing in your backyard,
16-meter
but
tower.
you've got something, yeah, but you've got something that you can run your whole house off. Obviously, you won't be able to supply your neighbor with electricity, but that is something that we are talking about and we are looking at. Um, because the concept remains the same. It's just your generator unit's going to change a
So
bit.
you could essentially use the you could essentially use this to solve the EV issue in South Africa as well. I'll tell you what I'm saying about the EV issue. When I drive from Cape Town to Plet, from Cape Town to Joburg, from Cape Town to wherever the hell, and it's often there's always an EV on the road. It's either a Jag or it's that one guy who's got a Tesla Model Y in this area, you know, and they'll come past you. You know, if you leave from Knysna, they'll come past you like absolute bat out of hell. But by the time you get down to like Riversdale, they're cruising at 80 because they're running out of charge and they need to calm it down until they can get to the next charger, which is in Caledon. So the hell, like Jag has built some chargers, right? In my area, if I want an EV charger, there's little tiny ones that like trickle charge and take forever. If I want a proper charger, I have to go to Caledon, up to the casino. That's an hour away. I mean, that's dumb as hell. So if this is scalable down to a house level, in theory, it should also be in the middle, capable of running like a bank of charging stations for EVs at a much smaller footprint than doing it in other ways, and a much more sustainable way than doing it in other ways.
I'm almost 100% sure it's possible. Look, it's a conversation. We haven't gotten to that point yet, but it's definitely a conversation I'll have with the boss man. And it's definitely a possibility because the fact is you'll be able to put it in the middle of nowhere, and it's also a thing that you're looking at. I mean, if you look at your fuel pumps and stuff that's running from Mozambique to Natal and so on. I mean, those pump stations are in the middle of nowhere and they're reliant on electricity. So, maybe it's a thing that we put up a plant by each of those pump stations and they become completely sustainable by themselves. You don't need someone to supply electricity. So it's a possibility. It's like I said, at this moment, it's early stages. I can't really say where it's going or where it's gonna go. It's it's basically, how can I say, at the moment it's like shooting at the target and you can see it, but you can't see where you're hitting it because it's at a
I can
distance.
see that for sure. It's bloody interesting, man. I think also for where I live in Gansbaai, right? So you've got Cape Town, and then about an hour and a half away you've got Hermanus, and then half an hour away from that you've got me, right, in Gansbaai. So I'm like 2 towns removed from anywhere useful. And when the fires kick off, because we're a fire-driven ecology with a phone boss out here, when the fires kick off in fire season, like just happened, the power goes down because the poles burn down. Then Eskom has to come in because it rains immediately after the fire because all of that smoke and stuff goes up, it
Yeah,
forms around, it dumps. So then our deep ass clay mountain mud gets so soft that the Eskom trucks, even the big off road trucks, they sink straight down, like they bog to chassis. And we had it 3 years ago now. I climbed one of the mountains to go and have a look at what they were busy repairing up there. I mean, in a storm, my boy. Like I was like climbing up a river essentially. And I got to the top, and there were like 12 Eskom trucks, fire trucks, other municipal vehicles that had been brought in to drag the other ones out. They were all bogged to chassis. They had to wait for that rain to
yeah.
stop. They had to wait for the ground to dry. They had to then lift these all out with another crane, which also bogged the chassis. It was ridiculous levels of mess. So they had to do all of this cack, which meant we were without electricity for about a week. And even that was pretty well good going because they just worked like 18-hour days to get all this shit done. People talk shit on Eskom, but at least our local dudes, they work their asses off when things like that happen. I am now fantasizing about the next fire season and having one of your systems in my backyard, or the town having one, each town having one, so that length of, I mean, we also get cable theft in South Africa.
Mm.
So that length of cable that's between me and Cape Town, if that gets stolen, if that gets burnt through, if that, whatever the hell, we no longer need it. Leave it burnt. Bugger it. Don't replace it because now we've got this system. Each town kind of a little more isolated with their needs. Just sounds better to me, honestly.
Yeah, and I mean it's like if you look at at your alternatives like solar farms, wind farms, I mean, if you look at the footprint that that leaves in your backyard, I mean, I think Orania just put in a solar farm. I think it's like 30,000 square meters
Jeez,
for
that's
solar panels and batteries and all of that. Now you take that away and you put two plants in, which is 81 square meters. I mean, look at all that land that you've got available for other things. Or like we, I mean, you're also a BMX rider when you say it's like more space for
yeah, yeah,
activities.
exactly. Put some ramps in, why not? The I mean, this is probably going to be one of the last things I ask you because I mean, there's so many things I could ask you. With these systems, if you could, I'm not asking for realism here, right? I'm not asking for realistic at all. But if you could daydream a timeline, by 2027 we want to be here, by 2029 we want to be here. What are you thinking in terms of rollout? So if major retailer says, yes, cool, here's money, build a thing, and you get another person on board who's like really big, right? Really big, needs a lot of your units, and the money starts coming in. What is your kind of ideal growth pattern look like? I know initially you said that you were pushing for eventual acquisition of the company, which is, obviously every business owner's main thing most of the time if they're a big enough business. But how long do you want it to take to get there?
Realistically, if this thing kicks off, I think that my father-in-law and them will maybe step away within the next 2 years. I mean, they're already talking retirement plans and all of that. And dude, if to be honest, if it does that well, then I don't need to be involved. I'm looking at maybe retiring before I'm 45.
Fantastic. Fantastic, dude. More time for adventure bikes and bikes in general.
Exactly. And I mean, it's like I've always had this daydream that I want to own a massive game farm and you know be able to invite friends over and go nuts with off roads and all of that. So that's where I want it to be. But it's like I said, at the moment, it's a bit of a hit and miss thing. So hopefully we have a hit soon and then we can realistically start dreaming.
That's awesome, man. What
Yeah.
is your handle on, so like Instagram, things like that? I'm assuming you're on those, eh?
Yeah, personally, it's just at Melchior25 on Instagram. And yeah, Facebook, just look for Melchior Geldenhuys. I'm all over the place.
I'll put the links in the thing for you because this is obviously a super interesting, so interesting I could puke in fact, but you also do other cool shit like you go ride adventure bikes out in the desert, you go on these long treks, you do a bit of overlanding, you do all sorts of cool stuff. So go and follow the life of Melchior, dude. He's doing some cool shit.
Yeah.
That's awesome, man.
Yeah.
Thank you for answering my
No,
questions, man. That's
100%.
and I'm gonna get you back on here when we're a bit further down the road and you can tell me how far you've come.